Okay, good afternoon, ore diggers, and a hell of a happy new year to you all. I'm Ruth Jones with the Office of Alumni Engagement, coming to you live on the Mines campus. It's great to see everybody here today as we kick off a new year of Lunch Bunch, which are our monthly opportunities to shine the spotlight on the people and the programs that make Mines truly exceptional. If you're joining us for the first time, welcome. We're really glad you're here. It's always good to see your face. Please turn your cameras on. And if you're a returning lunch buncher or a regular attendee, thank you for your continued support. It's always great to see you all on the call each month. In just a moment, we'll say hello to today's featured speaker, Dr. Mark Jensen, Grandie University Chair in Nuclear Science and Engineering and Professor in the Chemistry Department, to learn how this nationally recognized program advances education, research, and policy. This is going to be super. But before we start, I have three quick reminders, as I always do. If you've got a question during the program, please feel free to use the chat, the raised hand icon, or as Dan says, one of the fun little icons down there to encourage the effort and the energy. We appreciate that. Or you can simply just unmute and chime in as we go along, if that's okay with you, Mark.
Yep.
And of course, a reminder that all of our Lunch Bunch programs are recorded and they can be accessed on the Lunch Bunch page of our alumni website at weare.mines.edu, which is where you all went to register for today's program. So if you missed a program or you want to listen to one again, or you want to share it, forward it to a friend, be sure to visit this page to access our complete archive of recordings. There's quite a robust collection what we're very proud of. As always, if you've got ideas for future speakers and topics, we want to know about them. Our spring lineup, in fact, includes several that you have suggested along the way, including next month's, which I will talk about before we sign off today. So keep your ideas coming. And of course, we will always do our very best to make them happen. So with that, let's get rolling. Please help me welcome Dr. Mark Jensen to Lunch Bunch. Mark.
Well, hi everyone. It's such a pleasure to be here with you today. Um, One of my favorite things about being at Mines is getting to meet and talk with alum. And so, sometimes I'll just be out somewhere and an alumnus will come up and say, "Oh, you're from Mines." That's just one of my favorite things to meet alumni and hear about their uh, their lives and how they're doing. So it's a real honor and pleasure to be with you today. So um, so uh, I am the director of the interdisciplinary nuclear science and engineering program. I've been at Mines for 11 years. Before that, for 20 years, I worked for the Department of Energy at Argonne National Laboratory doing research into the nuclear fuel cycle and nuclear energy. And when the chance came 11 years ago to come to Mines, it was just such a perfect fit. And Mines is such a great place. I don't know how anybody could turn it down and go somewhere else. But it's been a great 11 years, and I look forward to more time working with the awesome students and my colleagues here at Mines doing that. So it's a real pleasure to talk to you today about nuclear science and engineering. And one of the things that makes it fun is that, well, we're at a really interesting time in nuclear science and engineering. And the amount of interest and activity in nuclear energy is unlike anything I have seen in my lifetime. And it's, not a day or two goes by where I don't get something in my news feed that there's been some interesting new development or breakthrough or new agreement signed trying to advance nuclear energy. And so it's a really great time for our students to be going out into the world and making their way in nuclear engineering. And it's a great time to be a scientist and a researcher in this area because there's just lots of opportunities and work that we've been doing over the years being recognized and put into practice. So it's great to see the renaissance of the nuclear renaissance right now. So, um, I don't think many of you are going back to school to study nuclear engineering now, but the students that are graduating today, why did they want to study nuclear engineering? So let's just start there. Well, in case you didn't know, it's still today, 19% of all the electricity in the United States is generated from nuclear energy. And that in 2024 accounted for 44% of all the low emission electricity generated in the United States. And so uh, the death of nuclear energy was greatly exaggerated. It is still a very important part of our energy mix. Um, Nuclear energy can do things that nothing else can do. The energy density in the nuclei of atoms is a million times more than the energy locked up in chemical bonds. And so this allows us to do things and go places that we could not go with chemical fuels or solar energy for that matter. Did you know that every year there are 20 million nuclear medicine procedures done in the United States? Nuclear and radiological engineering is an important part of that in producing, purifying, and delivering these radioisotopes for diagnosis and treatment. And this is only growing. In the area of national security, nuclear remains important. We have people from mines that have gone on to work in the areas of monitoring the Non-Proliferation Treaty and the compliance of other countries to their treaty obligations in detection of weapons of mass destruction, specifically nuclear weapons, and people that maintain our nuclear deterrent. And then, why didn't it advance? There we go. Oh yeah. And then over the years, we have generated an enormous backlog of nuclear materials that we need to treat and dispose of. And so there's a tremendous amount of work going on there, both on federal sites and for civilian sites and the decommissioning and decontamination of retired reactors and civilian nuclear facilities. So those are things that 4 years ago, 5 years ago, students might be thinking of. But what about today's students? Why are they going into nuclear engineering and what are they looking? Well, one of their big interests are small modular reactors. And so these are smaller nuclear reactors than the ones that we use today to generate commercial power. They have several advantages, and the very first ones will be coming online in the next couple of years. The nuclear community is excited about these because they hold the potential to improve the economics of nuclear power and make some things sort of possible that aren't possible today. And when I read student applications, probably 7 out of 10 say, I want to work in nuclear energy and developing small modular reactors. We have significant needs in the domestic supply chains for nuclear materials to supply the next generations of reactors. And mines, with its emphasis on the nuclear fuel cycle and our expertise in chemistry and materials and earth and environment, stands in a unique place among nuclear engineering programs in the United States to help address these issues. Space nuclear power. This is one of the things that nuclear can do that other things can't do. And in fact, it was just 2 days ago that NASA and the DOE signed a new memorandum of agreement to deploy reactors on the moon for lunar missions within 5 years. So there's need to accelerate their work in space nuclear power. Another interesting topic is nuclear fusion. While that's not a main emphasis of our program, nuclear fusion is closer than it ever has been. And I'll talk about this a little bit later and maybe give you a unique perspective on nuclear fusion. As I alluded to on the last slide, nuclear medicine and treatment is only becoming more important. We have work going on at Mines in isolating radionuclides for sort of the cutting edge of nuclear medicine. Yeah, and then another just interesting thing that often doesn't factor into students' decisions about this is that the demographics of the nuclear workforce is decidedly on the gray end of the spectrum, and the civilian nuclear programs, as well as the federal nuclear programs, recognize this. And there are a lot of programs and interest in improving the pipeline of nuclear savvy workers. And they can look forward to a long and interesting career with nuclear energy and nuclear related things. So. All right, so that's why people might go into nuclear science and engineering. Why are they coming to Mines, and what about the program? So, well, you may or may not know that our nuclear science and engineering program is the only nuclear engineering degree program in the state of Colorado. And it was founded in 2007, so we're just coming up to our 20th birthday here. As a faculty-led initiative. It was originally spun out of Mines' expertise in nuclear materials, especially from our association with the Rocky Flat site, the uranium mining and environmental science, and the nuclear physics expertise at Mines. And so those three loci of expertise on campus came together to put together our interdisciplinary degree program. Over the last 20 years, sort of the focus has shifted some. And as you'll see, we have a lot of other departments and a lot of other expertise involved in the program today. We are an interdisciplinary program, and we only offer graduate degrees at this time. And I'll talk a little bit about the interdisciplinarity of the program and how that attracts and helps students with their learning. So, as far as degrees go, we offer a non-thesis Master's of Engineering degree, a thesis-based master's degree, and a thesis-based, of course, PhD degree in nuclear engineering. And so now, as far as the undergraduates go, we do have a combined 4+1 degree option for undergraduates. And so Mines undergraduates can get a bachelor's degree in just about any major on campus and stay for one additional year and also earn a non-thesis master's degree in nuclear engineering to go with that bachelor's degree. Some students choose to pursue a thesis-based degree as a Mines combined student, and so they will stay on longer than a +1 year after they complete their coursework to do their thesis research and write their theses. So, as far as the people in the program go, well, at this time, we have 7 what we call core faculty. I'll introduce you to them later. And then we have another 9 what we call affiliated faculty. And so the affiliated faculty are faculty that can advise graduate students and sometimes help us with teaching courses and are involved in nuclear research, but they don't really help determine the direction of the program or teach our core nuclear engineering classes. Depending on how you count things, we have what I would call 55 nuclear students right now, graduate students in the program. So 35 of these are actual nuclear engineering students pursuing one of our graduate degrees. But we have another 20 students that I'm calling here nuclear science students. And so these are students that are pursuing other graduate degrees on campus, but they're doing their thesis research with our nuclear engineering faculty in some aspect of nuclear energy or the nuclear fuel cycle. And so that makes us kind of a mid-sized nuclear engineering program. I guess I didn't say it, but there are about 35 nuclear engineering programs around the country. And the biggest ones on the graduate level maybe have 150-ish graduate students. So, and of course, there are undergraduate programs too that go with many of those. Our students are great. Our students are a treasured resource, that, I mean, to our alumni, you are what makes Mines great. And you did, and our students still do today. Just some of the kudos for our students. Before COVID, 3 years in a row, our graduate team were finalists in the American Nuclear Society graduate design competition. And so they went to the ANS national meeting and presented their work. They published their work in the ANS journal. And to do that like 3 years in a row was like unheard of. We've also had 10 students, so like more than a student a year, win the national award from the Department of Energy for their research papers. A competition for the best research papers in the country. And so as far as our students go, they're just top notch and are doing great. So I said we're an interdisciplinary program, and that's unique among all of the graduate nuclear engineering programs in the country. Some are nuclear engineering departments, and they sit by themselves as a department, a traditional academic department. Some of them are degree programs within another department. Oftentimes it's mechanical engineering, but if you look around the country, there are nuclear engineering programs in civil and environmental engineering, material science, chemical engineering. There's a variety of departments that play host to nuclear engineering degrees around the country. At Mines, we are the only program in the country that is not a department and does not sit within a department. We are independent collaborators with the departments on campus. Different departments on campus contribute faculty and classes to our program and help make the program what it was. So at the center of the program, we have our nuclear science and engineering program, but then around us we have our affiliated departments. And so we affiliate with the physics department, especially the nuclear physicists in the physics department, the nuclear and radiochemists like myself in the chemistry department, faculty in materials and metallurgical engineering, in steels and in nuclear materials, chemical and biochemical engineering. Our true nuclear engineers sit in the mechanical engineering department. We partner with the undergraduate energy minor to help offer nuclear engineering classes to the undergraduate population. And then, hopefully you know, but maybe you don't, we have a long partnership since 2007 with the U.S. Geological Survey and their research reactor, the GSTR, at the Denver Federal Center. And so the USGS operates a 1 megawatt research reactor that we have an agreement with them to have reactor access for both teaching and research. And in fact, right now, actually, Mines faculty and students are helping the USGS keep their reactor operational and compliant with NRC regulations, because the USGS is had several people leave as a result of the government downsizing earlier this year. And so to be legal, we're pitching in to help them keep the reactor up to date. So these are our current set of core faculty. And so we have a set of radiochemists, Professor Jennifer Schaefer, Tom Albrecht, and myself in the chemistry department. We have long expertise in working with radioactive elements, both on the front and the back end of the nuclear fuel cycle. We have a set of 3 nuclear engineers in the mechanical engineering department, including Valerio Mascalino, who just started at Mines this fall. He comes to us from Argonne National Lab, where he led efforts in reactor modeling and in converting research reactors around the world to run on low enriched uranium instead of high enriched uranium, to reduce the risk of nuclear weapons proliferation. And so, Valerio worked in that for a few years before joining us. I got the pleasure of co-teaching with him this fall, our Introduction to Nuclear Engineering class, and the students really enjoyed his expertise and energy in nuclear reactor physics and reactor operations. Our other core faculty member is Uwe Greife in physics. Uwe is the longest time member of the NSE program. He's been with us since essentially the beginning. He was the director of the NSE program for a while, and so he brings a lot of expertise. In addition to Uwe, there are other nuclear physicists, Kyle Leach and Fred Sarazin in physics, who are nuclear physicists who are affiliated with the program. And like I said, we have faculty in chemical and biological engineering, materials and metallurgical engineering, that are also part of the program. So they're not our core faculty. So, so one of the things that we really that Mines values a lot, and we value in the program, is trying to balance giving our students the strongest and deepest graduate level understanding of the models and theories underlying nuclear engineering, right? But we want to combine that with like in-depth practical experience with the codes and equipment and materials that they're going to be facing when they go out into the real world. And so Mines has built world-class research facilities to do these things. We use these for our research, but we also use them for our classroom work and student education too. And so I just highlighted here some of the ways in our curriculum that we make sure that our students are up to date on the latest sort of hands-on things. And so we have a specific class for the students on utilizing the modern nuclear codes to model reactors and nuclear systems in our computational reactor physics class. A pinnacle for the students of their education is our nuclear reactor laboratory class, where 1 day a week they go out to the reactor and work at the reactor for a whole morning. 10 years ago or so, we got a grant to revise the control room for the nuclear reactor to make it suitable for teaching. And so here's a picture of our students in the revamped control room so they can all see the control panel and take turns as operators. We've added classroom labs to our applied radiochemistry class, so the students actually get to handle radioactive materials and do experiments with them in applied radiochemistry. The physics department offers our radiation detection and measurement class, where the students put together detectors and really learn how they work. And then our capstone, all of our degrees, whether it's a non-thesis degree or the PhD degree, all of our students, their capstone is our reactor design sequence, where they work together in teams to solve a problem in nuclear energy, oftentimes designing a reactor. So this is our curricular approach to making sure that that our students don't just know the books, but they can operate in real world settings. So yeah. And while we don't have, I see the pictures here on the screen, that reminds me, while we don't have a field session like the undergraduates do, one of the things we've been trying to do is to get at least some of the students out on some field trips. And this is the pictures on the far right are from 2 summers ago when we went out to Nucla, Colorado to visit the Sunday uranium mine out there, and got to go down in the mine, and yeah, the students loved it, and well, the faculty loved it, and the mining company enjoyed having us, and so we're trying to help them see the whole fuel cycle. So, all right. So sort of the last topic as far as the program goes is I wanted to just give just a quick overview of the sort of research that goes on in the nuclear science and engineering program. And so overall, the NSE program is organized around the life cycle of nuclear energy. And this really plays to MIND's strengths in materials, in mining, in environment, in chemistry. And we unique to all of the nuclear engineering programs in the country, can address things going on in the whole nuclear fuel cycle, from exploring and mining uranium to taking the nuclear waste and putting it back in the ground at the end. So some of the projects that have recently concluded or are going on now on the front end of the nuclear fuel cycle. We've worked with some companies in their processing of ores and uranium ore concentrates to help improve those and get around some of the difficulties that they have in producing materials. We've looked at the stability of intermediate compounds like uranium fluorides and how they age and what happens to them if they sit around for a while. We've done more systems engineering studies where we look at like the ideal placement of sensors and detectors in nuclear facilities to ensure that nuclear material is not being diverted. Tom Albrecht has a large program right now in looking at recovering and recycling radium from tailings. And this program is starting to interface with some of the local mining companies and the possibility of recovering radium for nuclear medicine from mine tailings there. So that's the front end of the nuclear fuel cycle before the uranium goes into a nuclear reactor. On the back end of the nuclear fuel cycle, or sorry, in the middle of the nuclear fuel cycle, we have research going on in the fundamentals of nuclear fission, the nuclear reaction that we use to make nuclear electricity, research in molten salt reactors, and the corrosion and chemistry that's going on in these molten salt reactors, sensors for molten salt reactors. You have this reactor with incredible amounts of radiation operating at, say, 900 degrees centigrade, and with reactive liquid flowing through the reactor. How do we know what's going on and what the state of the chemistry in this reactor is? Yeah, well, we need new radiation resistant sensors to follow that. We have faculty that have been working to take baseload nuclear power and understand at a systems level how we integrate this with intermittent renewable energy sources like wind and solar. While we concentrate on fission energy, we have Colin Walden in chemical and biological engineering, who's looking at fuel for nuclear fusion reactors and how we separate and purify tritium to use in fusion reactors. After the fuel comes out of the reactor, we have what we call the back end of the fuel cycle. And there we have a lot of research going on, focused on materials and chemistry of nuclear waste, how we can produce specific isotopes for nuclear medicine, for space power, and for other applications. An interesting set of programs going on right now is using cosmic ray muons from space to essentially X-ray nuclear waste and see what's inside concrete casks of nuclear waste. And so that's a partnership between Mines, Los Alamos, and the Idaho National Lab. Mines leads this program. In examining nuclear waste and its safety. So just a quick overview of some of the research that's going on at Mines. So, we're moving on. So I'll just take a break right now, and why don't we just open it up for questions? And I think, yeah, if we don't have many questions, I have more I can talk about, but.
I have a question.
Yes.
Yes, hi, Dr. Jensen. This is Peter Ewing.
Hi, Peter.
Hi,
it's nice to see you face to face.
Yes, I'm trying to adjust my camera. Sorry, I don't see my whole face in there. I apologize. I'm on my phone. Yes, I was just curious. I was disappointed. This is more on the industry side, I guess, but in the space nuclear effort, I was disappointed to see that the Draco program, which I think is the only, as far as putting an astronaut in a vehicle that would have nuclear propulsion for a manned spacecraft. I think that whole effort was canceled, but I wanted to get your opinion. I also read things about the maritime sector is potentially expanding with what the Navy has been doing for many years, but that could move into commercial maritime. And I think maybe with different reactors than what the Navy's been using. But would you see, I was just going to get your opinion as a professor, if you think there would be any way to blend, or if the maritime projects took off, could there be a smooth transition or any kind of transition between expanded maritime use of nuclear and nuclear rocket propulsion for manned spacecraft eventually. Is that any
Yeah.
direction to even think
Yeah.
about?
Um, I I think that it's pretty likely that advances or developments in maritime propulsion can indirectly help space propulsion. Um, but sort of the considerations and approaches um, are probably going to be different. Um, in maritime propulsion, you want to keep the reactor relatively small, and you don't want more weight than you have to have. Um, in space propulsion, you want to keep the reactor very small, and you want no extra ounce than is like the minimum. Um,
Yeah.
and while both maritime propulsion and space propulsion are going to use the heat generated by the reactor for the propulsion. Sort of the way they use it is different. And so, right, like I could see reactor designers that worked in maritime space and maybe um, moving over to work on space power. But I think that like direct lessons learned or direct application is not very likely. So,
Okay. And if I could just follow up, do you do you see any um, desire anymore? And I know that's a big question, but also know I'm aware of a company in Austin that says they are working on fusion fusion space propulsion. Um, would that be for manned? I don't know if you know anything about that, but could astronauts get on a fusion powered rocket? I guess I need to read more about that company. But how about the U.S. government itself? Do you think there's any desire to put astronauts anymore at all on nuclear powered rockets, or did that die when the Draco? Is that going to be 10, 40 more years before that's even
yeah,
reconsidered by the government? Or-
uh, I don't see a need for that until you want to have manned missions, beyond the moon,
Okay, okay,
right? And so, yeah, I,
okay, okay,
so I I suspect I suspect that this is kind of a matter of NASA and the federal government looking at the budget and saying, okay,
right, right.
like this is important, but it's not important today. And
Yeah, yeah.
space nuclear, the closest thing that maybe we need is stationary reactors for a lunar base.
Okay, okay.
And so let's put our money there in the short term.
Thanks for the time. I really appreciate
Yeah.
your answers. Thank you very much.
Yeah.
I
So
have a
there are some
question.
questions in the chat.
I have a question. Oh,
Joe?
yeah. Do you look at thorium reactors at all, the small modular thorium reactors in your program? Or do you just concentrate on the uranium reactors?
Yeah. So um right now our thorium fueled molten salt reactors are kind of a big subcategory of molten salt reactors. Our molten salt reactor work right now is on uranium fueled reactors and looking at the chemistry in these molten salt uranium reactors. So, um, um, yeah, so we don't have anything actively going on in the thorium space at the moment. I like thorium. I like the thorium fuel cycle. I think it changes um, a lot of things about the back end of the fuel cycle and your waste. And so I really like it from that perspective. Um, many kind of traditional nuclear engineers, well, maybe not traditional, many older nuclear engineers don't like it so much for a practical reason. And that practical reason is how long it takes to qualify a fuel for a nuclear reactor. And so they look at this and go, it's going to take 20 years before you have a fuel that you can put in your thorium reactor. So, like on the commercial scale. So, um, it's a hurdle. It's a hurdle. There's research that definitely needs to be done there. But
Yeah, well, thank you.
yeah. So, Joseph Long has a question in the chat about SMRs and SMRs that are coming online shortly. So, um, so right now there are 4 companies that have signed agreements with the Department of Energy to, let's say, test their small modular or micro reactor technologies actually by this 4th of July. And they are scrambling to meet this deadline. I am suspicious that any of them will actually be able to make the Independence Day 250th anniversary of our country deadline for this. If for no other reason than even with DOE oversight instead of Nuclear Regulatory Commission oversight, I just don't see how all the relevant safety analyses are going to be done in time to even turn on and test. But that's out there as a goal. Sort of beyond that, there are 2 or 3 companies that have agreements with the Department of Energy to build and test at a real scale small modular reactors at the Idaho National Laboratory. This includes Oklo, and there are so many of them, I have a hard time remembering. I don't remember the second one. At Oak Ridge National Lab, there's another set of companies that have an agreement with the Tennessee Valley Authority to build test SMRs at Oak Ridge National Lab. And then in Texas, we have X Energy that has an agreement with ExxonMobil to, by 2027, I think it is, start up 2 SMRs in Texas to provide not electricity, but process heat for chemical processes for ExxonMobil. So that'll be a first in the United States where we really use the reactor for its heat rather than taking the heat from the reactor and turning it into electricity or maybe propulsion. So that's kind of new. So that's what we're looking for SMRs. In the fusion space, there are 3 companies that have said they are going to demonstrate ignition of a fusion plasma in the next, 2 years. One company said they were going to do it in 2025, and it hasn't happened. So I guess this year will be the year. And so we'll see about that. Those companies, the fusion companies, are shooting for, the most ambitious is shooting for, they have an agreement with Microsoft to provide them 50 megawatts of electricity in 2028. So they're optimistic that they will have fusion electricity on the grid by 2028. So we'll see. We'll see.
Mark, I see a comment in here from Dr. Trefny. John, do you want to, comment on your comment? I think it's pretty awesome that we have ties to nuclear clear back to uh, the 50s, and what a history there. Do you want to say anything about that? Can you all see the comment?
I can see the comment.
Okay, good.
Very interesting.
Okay, yeah.
Yeah, well, I knew Jerry Morse for quite a while, and I think that's an important part of mine's history that he invented this, or he developed this nuclear um, uh, source that was deployed in space, and he actually got invited to the White House to meet with President Eisenhower at the time to brag about it. And then, of course, there's the legend of the processing of the radium for the Curies that goes way back before that.
Wow.
So I just think it's interesting to keep remembering this history that Mines has been involved in for so many years.
How far we have come, right? My goodness. Thank you for sharing that. Also see a comment from Sean Cole. And if I may, I'll just read this in case y'all can't see it. But does Mines get involved in nuclear policy discussions?
Absolutely. Absolutely. So actually, when the Nuclear Science and Engineering program was founded, what is HAAS, the Humanities, Arts, and Social Sciences division of Mines, was actually one of our partner departments. There was a tenure track professor that was part of our nuclear science program who her thing was nuclear environmental policy. So she's no longer with us, but our faculty certainly remain interested in these areas. One of the things that the program does is we have our weekly seminar series. But within our weekly nuclear seminar series, we also have a series of special Grandy lectures where we invite thought leaders from a variety of areas, nationally and internationally, to campus to come and talk. And so we've had assistant secretaries of energy, chairman of the Nuclear Regulatory Commission, leaders of the DOE national laboratories, and eminent scientists and engineers. And a lot of times what they come to talk to us about is nuclear policy. We also do things like host workshops to try and develop ideas and push things forward. We work with the state of Colorado and the legislature on nuclear matters. Last spring, the state Senate invited me to come out and give the state senators and representatives, for that matter, and their staffers a nuclear energy 101. And how this interfaces with Colorado and things that go there. We help sometimes testify for nuclear related legislation here in the state of Colorado, and we certainly do nationally as well. There aren't that many nuclear engineering departments in the country. And so we do band together to advocate for both nuclear education and nuclear policy at the federal level. And so we participate in that. Yeah, we're just talking about an op-ed on funding for nuclear engineering education. And the U.S. government under the Biden administration committed as a goal to tripling the amount of nuclear electricity the United States puts out. Even if we only double or increase by 50% the amount of nuclear electricity that we make. There are huge workforce needs, huge pipeline needs there, and huge educational needs that are kind of going unrecognized in the halls of Congress. Oh, hey, Jerry, I see your question. Yeah, so a couple of years ago, um, Mines and the University of Regina were linked together through a Mines, Mines, a retired Mines faculty member who had connections at both. And so Walt Copan, our soon to retire vice president for research, and if you alumni had not gotten a chance to meet and interact with Walt, let me tell you, you missed something. Walt was such a treasure and has been such a help to Mines and the nuclear program. Massive applause and shout out for Walt. But anyway, so under the auspices of the vice president for research and the provost's office, Mines and the three universities in Saskatchewan, the University of Regina, the University of Saskatchewan, and Saskatchewan Poly, Sask Poly, set up a sort of reciprocity educational agreement that centered around nuclear energy, mining and minerals and critical minerals, and carbon capture and a few other areas of related interest. Kind of in the area of policy, actually, the University of Regina, of the three Saskatchewan institutes of higher education, was the most interested in nuclear policy. And so we've had a couple of faculty members from the University of Regina to Mines campus for our nuclear seminar series and interacted with them. When Jeff King was here, there was a good progress in developing joint curricula. Unfortunately, Jeff's departure to start a new nuclear engineering program in Tennessee kind of put that, sapped our energy in the curriculum development part of that. But Valerio has new ambitions and is working in that area. So we think it's an area that's ripe for things. As I'm sure you know, Jerry, right? Like SMRs and Saskatchewan are a big thing, and yeah, there's the opportunity to they will have one online long before Colorado has an SMR online.
So I think,
And
Mark,
probably-
I think that's the point, is that there are probably 2 or 3 that will be built in Saskatchewan long before we build them in Colorado. The other thing I'd like you're involved as well in the Wyoming small modular sodium cooled.
We are working with TerraPower.
Yeah.
We have active research grants with TerraPower to developing chemistry and stuff for their reactors. The molten salt sensing work is joint with TerraPower to help them understand and build the sorts of sensor arrays that they need to make this thing work.
Yeah.
So
Good, thank you.
Mark, we're about 1 minute until we wrap. So do you, lots more to share, I'm sure, but if you've got another screen to share or slide to talk to, we could quickly squeeze that in before we say goodbye to everyone.
I think the only at this point, the only slide I would impose on you would be the slide that says thank you for coming and listening. and one that showed my email address, in case you had more things that you wanted to reach out to. But maybe I'll just put it in the chat here.
That would be lovely. And
So-
while you're doing that, let me just do an about face, pun intended, for our program next month, which will feature the Minds ROTC program. How many of you remember when ROTC was a required course, your first and second years at Minds, right? Lots of heads nodding. Well, we've come an awfully long way, and you might not know, or maybe you do, that Minds was among the first 4 colleges in the country to establish an ROTC program and commissioned its first graduating class in 1921. So next month, we're going to hear from Captain David Hermerding, who runs our ROTC program, for a look back where we've been, what we're doing now, share a day in the life of a cadet, what they're studying at Mines, and some of the diverse leadership positions they pursue and land in after they graduate, and talk about what's coming up. So we hope you'll join us for that. That'll be on Thursday, February 19th, noon to 1, right here. So you can register the same place you signed up for this one at weare.minds.edu. Okay. Oh, Ron, how fun. Yep, the old football field, right? Love it. I want to hear all of that. All these great ROTC stories, for better or for worse. So before we say goodbye, I just want to thank again Dr. Mark Jensen for his time. What an incredible presentation. And Mark, did you put your email in the chat? You know what?
did.
Let's see. Doo-doo-doo-doo. I am not seeing it on my screen, but
Okay, well, here, I'll
that
do a
might
quick
just be
share.
me. That might just be me. We thank you all for carving out time today, and hope to see you next month. Mark, thank you again. Exciting things. And of course, as always, Minds is at the forefront of such an amazing industry and developments down the line, a long and storied past, but so much for the future.
Mhm.
So we appreciate all the information. Thank you all. Claps, claps, claps. I love all the claps. You guys are great. Make it a wonderful day, and we'll see you soon.